So we'll solve numericals based on system properties. The question which can be asked would be in a form: determine whether the following system is static, causal, linear, time invariant and stable. It means that for this given system yn is equal to xn plus n xn plus 1, we have to check all the system properties for a given system. So we have to check all the system properties for a given system. So let us start by the very first. Let us check the static or whether the given system is static or dynamic. So check for static system. So let us try to understand the terms in the system equation. So system is comprising of xn plus n into x of n plus 1. So with respect to nth time instant, xn becomes the present input and x of n plus 1 becomes the future input. And we know that what is the basic definition of static system? If the output of the system is dependent only on the present input, output is a function of only present input, then you call the system to be static. Here in the given example, the output of the system is not only the function of input, but it is also dependent on input at some other time. Here output is dependent on future input. It is not purely only a function of input, and therefore we say that the given system is dynamic, as it depends on the input other than present state. Then the given system is dynamic. If this term would have been absent, then we would have said that output is only a function of input and therefore the system is static. But since there is a presence of input other than the present input, you call the system to be dynamic system. Let us check the next system property for the given system. Check for causality. So what is causal system? If the output of the system depends only on present and past values of the input, there is no dependency on future value of the input, then and then the system becomes causal. But here what do we observe? That output of the system is dependent on future input. There is a presence of future term in the input signal, right? Because of which the system becomes non-causal. If the output only depends on present and past, you call the system to be causal. But if there is a dependency on future value of the input signal, if the system depends on future input, then the system becomes non-causal. So our given system, as it depends on the future input, it becomes non-causal. Let us check the third system property, that is linearity. So we know that for the system to be linear, it should obey two properties, homogeneity and superposition concept. So we'll follow the steps wherein we will check these properties for the given system. So our given system is yn is xn plus n times x of n plus 1. So in step number 1, we will apply a part of input. We'll say let us apply x1n and measure the output y1n. So wherever there is input, we'll replace the input as an input x1n. So output becomes y1n is equal to x1n plus n into x1 of n plus 1. Now let us apply input x2n. So what would be output y2n? Y2n will be x2n plus n times x2 of n plus 1. In step number 3, we will apply weighted input to the system. So we will apply a weighted input a1 x1n plus a2 x2n, and we'll call the output to be y3n. So y3n is, as yn is a function of xn, we will replace this xn by weighted input in step number 3. So we'll replace this xn by weighted input a1 x1n plus a2 x2n plus n times, here the input is a function of n plus 1, When we are applying a weighted input, the weighted input should also be a function of n plus 1, and therefore the weighted input becomes a1 x1 n plus 1 plus a2 x2 n plus 1. So this is your system output for weighted input. Now let us try to simplify the given system. We will try to simplify the given system by collecting the A1 terms. So we will collect all the terms associated with A1 and we get this equation. We will collect all the terms associated with A2 and this is the system equation. So if you closely study the system equation, this part of the equation is nothing but your y1n. Is nothing but y1n. x1n plus n times x1 of n plus 1 is nothing but y1n. Similarly, the other part of the input x2n plus n times x2 of n plus 1, this is nothing but your y2n. y2n is x2n plus n times x2 of n plus 1. So in the next step, we will replace this term by y1n. We will replace this term by y2n, and we observe that y3n is equal to a1 y1n plus a2 y2n, which is nothing but weighted sum of input has resulted in weighted sum of outputs. Weighted sum of input has resulted in weighted sum of output, and therefore we call the system to be linear. The conclusion is the given system is linear as weighted sum of input has resulted in weighted sum of output. Therefore the given system is linear. Let's move to the next system property, which is time invariance. So we have to see whether the system output of the system changes with respect to time or is not changing with respect to time. So this is our given system equation. The steps is, we'll first delay the input by k units and record the output or call the output as y of n comma k. So we are going to delay the input by k units. So y of n comma k becomes, by delaying xn, it becomes x of n minus k. Delaying this term x of n plus 1 becomes x of n minus k plus 1. So we delayed the input signal. In first step, we delayed the input signal. In step number 2, we are going to replace n by n minus k throughout. So wherever there is n in the equation, we will replace it by n minus k and we'll call the output as y of n minus k. We'll call this output as y of n minus k. So y of n minus k is wherever there is n in the equation, system equation, we'll replace it by n minus k. So here xn becomes x of n minus k. Here we have a term n that also gets replaced by n minus k, and we have term x of n plus 1, n gets replaced by n minus k. So this is the output obtained by delaying the output signal. In first step we delayed the input. In second step, when we are replacing n by n minus k, it is as if we are delaying the output. So this is the output obtained by delaying the input. This is the output obtained by delaying the output. So we observe that both these outputs are different. When we compare both these outputs are different. So the output generated by delaying the output input signal and the output generated by delaying the output signal are different. And hence it means that the system is changing with respect to time. Therefore, the given system is time variant. We conclude here that the given system is time variant as the outputs differ. Therefore, the given system is time variant system. Variant means it is changing with respect to time. The system is changing. Response of the system is changing with respect to time. Now we check the last system property, which is stability. So for stability, we need to apply a bounded input to the system. So let us start by applying a bounded input. So we'll replace the input by a bounded signal, unit step signal un. With this, the system representation becomes yn is equal to un plus x of u of n plus 1. So wherever there is input in the system representation, we have replaced xn by un. It is as if we have applied a bounded input to the signal, because unit step signal is a bounded signal. Now we need to check whether a bounded input to the system is resulting in bounded output. Whether yn will be a bounded output is what we need to check. If yn becomes bounded, you will call the system as stable. If yn is unbounded signal, you conclude that the system is unstable. So let us try to sketch your yn signal. So yn comprises of two terms. Un, the unit step signal, wherein the samples are having, all the samples are having magnitude 1. Then you have a term which is u of n plus 1. So we are going to shift the unit step signal 1 unit. We are going to advance it. So signal starts from -1 and tends towards infinity, plus infinity. So signal is shifted by 1 unit. Now this shifted unit step signal is multiplied by n. This shifted unit step signal is multiplied by n. So when n is -1, the sample has a magnitude -1. When n is 0, 0 into 1 would be 0. When n is 1, 1 into 1 is 1. When n is 2, the magnitude is 2. When n is 3, the magnitude of the signal becomes 3. When n is 4, it becomes 4. So it means that these samples are increasing in magnitude as the time increases. And therefore, when we add un and n times u of n plus 1, definitely the addition of these two signals is going to be an unbounded signal, because the magnitude will tend to infinity. Adding these two will again result into an unbounded signal, and therefore we conclude that the given system is unstable. We say that the given system is unstable because the output yn is unbounded. Therefore, we conclude that the given system is unstable.